Hello, welcome to crackingmba.com. Today we are going to talk about divisibility rules in numbers. So some of the divisibility rules that we're going to talk about are divisibility by 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. There may be divisibility rules for other numbers as well, but these are some of the basics that are essential, and if you have a good grip about these divisibility rules, you're good to go. So let's deep dive. So first, divisibility by 2. This is the easiest of all. To test divisibility by 2, just check the last digit. It should be either be 0, 2, 4, 6 and 8. So basically all the even numbers. So if your last digit is an even number, it's divisible by 2. Simple as that. So if you see some of the examples on the right side, 248, 424 are all examples of numbers divisible by 2. 237 is not an even number, hence it is not divisible by 2. So if you see some of the sample questions, how they can be asked, right? Although the concept is simple, so you may be asked that a number is in the format of 237xy. How many such numbers are there which are divisible by 2? So we know that y should be an even number. So it can only have values of 0, 2, 4, 6 and 8, which is 5 numbers. And x can have any number from 0 to 9. So it's basically 10 numbers for x and 5 numbers for y, which is 50 possible numbers. Okay, so this is how you apply the concept to solve numericals. So let's move on. Divisibility by 3. So to test divisibility by 3, you just need to sum all the digits for that number and see if that sum is divisible by 3. Okay, so let's look at an example. We say 9234 is divisible by 3 because 9 plus 2 plus 3 plus 4 is 18, and that is divisible by 3. Similarly, 9236 isn't divisible because the sum is 20, which isn't divisible by 3. Okay, so how a sample question could be asked is a number is in the format of 428y. How many such numbers are there which are divisible by 3? Okay, so you know now that the sum should be divisible by 3. So you will say 4 plus 2 plus 8 is 14, and you need to add another number y, so that it's divisible by 3. So the only possible numbers can be 1, 4 and 7. Okay, so the total possible numbers that are allowable over the format 428y are 3. Okay, so let's move on. So divisibility by 4. To test divisibility by 4, check the last two digits and see if they are divisible by 4 or not. For example, to this on the right side you can see 4886224 is a long number, but you can immediately say it's divisible by 4 because the last two digits 2, 4 are divisible by 4, which is 24 is divisible by 4, hence the entire long number is divisible by 4. Similarly, you have another example 4578557. Immediately you can say it's not divisible by 4 because 67 isn't divisible by 4. Okay, next, divisibility by 5. The last digit should be 0 or 5. Okay, let's see some examples. We're saying 25, 85, 90, and this long number is also divisible by 5 just because the last digit is either 0 or 5. Similarly, you can see this long number 265642 isn't divisible by 5 because the last digit is not 0 or 5. Okay, so that's how you apply your divisibility rules. Going on to divisibility by 6. So for 6, we need to check if the number is divisible by 2 and 3, both 2 and 3, not just either of them, both of them. So if we see some examples, you can see 36, 48, 96 are all divisible by 6 because they are both divisible by 2 and 3. Now, to test the divisibility by 6, you need to apply the divisibility rules of 2 and 3, which we discussed earlier. Okay, and similarly, you can say 38 isn't divisible because although it is divisible by 2, it is not divisible by 3, right? 38 isn't divisible by 3, and hence 38 is not divisible by 6. So it should be divisible by both 2 and 3. Coming to the next number, which is divisibility by 7. So for 7, what you need to do is slightly different. So take the units digit, okay, the last digit, multiplied by 2, and whatever remaining number is there, subtract it from that remaining number. If that after subtraction the value that you get is divisible by 7, then the entire number is divisible by 7. Let's take an example to understand this. So if we take 987, okay, the last digit is 7 and the remaining number is 98. So we say 98 minus multiplication of 7 by 2, which is 14. Okay, so let's see the steps. So first multiply the last digit of 7 by 2, which is 14, subtract it from the remaining number 98 minus 14 to get 84. Now 84 is divisible by 7, hence 987 is divisible by 7. Now this is a small number. Let's take a larger number, say 164402. So here we apply several iterations. So we say 16440 minus 2 into 2, which is 4. You get 16436. 164 minus 12 is 1631. 163 minus 2 is 161. 16 minus 2 is 14. So 14 is divisible by 7, which means 164402 is also divisible by 7. Let's move on to divisibility by 8. Just like we saw divisibility by 4, divisibility by 8 requires the last 3 digits to be divisible by 8. For example, 28864 is divisible by 8 because 864 is divisible by 8. Similarly, 745865 is not divisible because 865 is not divisible by 8. Divisibility by 9, just like we saw divisibility for 3, the sum of all the digits should be a multiple of 9. Okay, so 4887 is divisible by 9 because 4 plus 8 plus 8 plus 7 is 27, and that is divisible by 9. 745865 is not divisible because the sum is not divisible by 9. Divisibility by 10 requires the last digit to be 0. That's it. So just check if the last digit is 0, then that number is divisible by 10. For example, 40 is divisible by 10, but 46 is not divisible by 10. Okay. Divisibility by 11 requires that you take the sum of all the digits in the even positions and the sum of all the digits in the odd positions, take the difference, whether it's positive or negative doesn't matter, just take the difference and see if the difference is either 0 or a multiple of 11. Let's take an example. So 979 is divisible by 11 because the sum of the even odd digits are 9 and 9, which is 18, and the even digit is 7, and if you subtract 18 minus 7, that is 11, and that is divisible by 11. Okay, if you take another example, say 5379 is divisible by 11 because the sum of odd digits is 5 plus 7, which is 12, and the sum of even digits is 3 plus 9, which is 12, and the difference is 0, and hence 5379 is divisible by 11. If you take 5378, you'll find that the difference is 12 minus 11, which is 1, and that is not divisible by 11. So 5378 is not divisible by 11. So some of the tips that you need to know for cracking the divisibility rules and questions related to that is you need to be very strong at the divisibility rules for each number, and the questions may not be directly asked to check for divisibility, but like we saw in the divisibility rules for 2 and 3, you might have to shortlist a possible set of values based on the divisibility rules and then arrive at the answer. Okay. So the closing notes are revise all the topics, revise the entire topic for all the rules, take the mock test in our Android app. That should help you strengthen your concepts to know if you're really good at what you have already learned just now, or if you have any questions, feel free to ask in our app under the dashboard section. Thank you.